This is 1. This is 2. This is 5. This is 2 5s. And this is 5 5s. We call that 5 times 5. 5 times 5 is 25. If we take this row and put it over here, we have the same number of dots, but its dimensions are kind of funky. But if we take 1 away, we see its dimensions are easy. 6 times 4 is 1 less than 5 times 5 was. 6 was 1 step up from 5, and 4 was 1 step down from 5. Well, if we put the lines together, you can call it 1 step out. Put the top row on its side, you have the same number of dots again, but if you take away the funky part, then you're left with 7 times 3. 7 times 3 was 2 steps out, and we'll talk about this later. Slide the top row off again, and you have the same number of dots, but if you take away the funky part, then you're left with 8 times 2. 8 times 2 is 3 steps out. Here's where it'll get fun. 9 times 1 is 4 steps out. You probably saw that coming. Now if you notice the pattern, you'll see that every step is another odd out. First we had 1, then we had 3, then we had 5, then we had 7. Knowing this will be really handy, and all we have to know is 5 times 5. 6 times 4 is 1 step out, so it's 1 odd less than 5 times 5. 7 times 3 is 2 steps out, so it's 2 odds less than 5 times 5. 8 times 2 is 3 steps out, so it's 3 odds less than 5 times 5. 9 times 1 is 4 steps out, so it's 4 odds less than 5 times 5. 6 times 4 was the first step out, so it's the first odd less than the step before it. 7 times 3 was the second step out, so it's the second odd less than the step before it. 8 times 2 was the third step out, so it's the third odd less than the step before it. And 9 times 1 was the fourth step out, so it's the fourth odd less than the step before it. This pattern continues way off in the distance. The important thing is the pattern is true, so no matter what problem you're given to solve, you can always relate it to one that is simpler. Solve this instead and you're just about there. Then make the adjustment just like you see here. That's multiplication you can do in your head. But wait, it gets even simpler than that. Notice how this just happens to be the combination of 1 and 3? You don't need this grid, you don't need the middle, you don't need to know how many odds out. You just need to see how far each number is from the 0. If you play with this grid, then this equation emerges, so if you're really curious, then knock yourself out. First, picture your numbers on a number line. Picture how far away each number is from the closest 0 and multiply these together. So your green number is 6. You'll combine this with your red number, which you get by stepping out until that closest 0. So instead of 13 times 12, you solve for 15 times 10. So 13 times 12 is 6 more than 150. Picture your numbers on a number line. Picture how far each number is from the closest 0 and multiply these together for a green number. You get a red number by stepping out until that closest 0 and solving for this instead. Add these two together and you get your answer. Picture your numbers on a number line. Picture how far each number is from the closest 0 and multiply these together for a green number. You get a red number by stepping out until that closest 0 and solving for this instead. Add these two together and you get your answer. Picture your numbers on a number line. Picture how far each number is from the closest 0 and multiply these together for a green number. You get a red number by stepping out until that closest 0 and solving for this instead. Add these two together and you get your answer. Picture your numbers on a number line. Picture how far each number is from the closest 0 and multiply these together for a green number. You get a red number by stepping out until that closest 0 and solving for this instead. Add these two together and you get your answer. So 17 times 12 is 14 more than 190. "18 times 12 is 16, no matter how you look at it, it is 16 more than 200. (22 times 21 is 2 more than 460. (24 times 23 is 12 more than 540. We have seen that 13 times 12 is 6 more than 150, but the reason that works is 13 times 12 is both 2 and 4 more than 150. If you have an area of 22 times 19, and you put this column back where it came from, you can see that you are just too shy of what would have been the area of 21 times 20. So to solve for 22 times 19, these are the two that you subtract from 21 times 20. This is the second kind of area. First, picture your numbers on a number line. Picture how far each number is from the closest zero and multiply these together for a green number. You get a red number by stepping in until the closest zero and solving for this instead. And since you went in instead of out, you will subtract the green number instead of add it. So 22 times 19 is 2 less than 420. (11 times 9 is 1 less than 100. 12 times 9 is 2 less than 110. 12 times 8 is 4 less than 100. 13 times 8 is 6 less than 110. When we finally realize that all numbers represent amounts and all products represent areas, then we should start asking ourselves, why are we using numbers at all? You see, this number represents an amount, but it looks nothing like the amount that we are thinking of. And it's confined to base 10. This also represents that amount. In some cases it's more versatile than base 10 digits, but it still doesn't look like what we're thinking of. This looks exactly like what we're thinking of, so it is the most literal, and it is the most versatile because this can notate any amount that we are thinking of. So why are we staying confined to numbers?